right, hey everybody. We're almost there. It's almost dinner time. So first I just want to, I guess, give a very short story about myself. So I'm from Visalia, California, born and raised. And so Central Valley, for those of you who don't know. And I come from many generations of farm workers. My family has been sprayed with, unfortunately, these pesticides and herbicides and all kinds of pesticides and chemicals for a very long time, which some of them actually had to move out of agriculture because of reactions. I never was drawn to agriculture initially. I was very Americanized, and I was a bodybuilder, and I was just like working out and tearing muscles all the time, and had 3 surgeries and on 30 pills a day, and I ended up not being able to pick up a spoon and feed myself. I couldn't walk very far. The doctors were like, "Oh, you're not gonna get better. You probably won't be able to walk again." And so it just got worse and worse and worse, and I decided, I was like, let's look to nature. Like, I see all these strong animals in nature recover quickly. So I was just encouraged. I felt nature had answers. So I started studying. I started becoming educated. I grew my own garden. I actually had to pay someone to grow my garden initially because I couldn't pick up a spoon. And within 1 year, I was doing handstand push-ups. So that was pretty amazing. Just huge change for me. Now I actually grow organic, nutrient-dense food for a whole bunch of people, whether they're home gardeners or agriculture, starting to work with municipal, with nature preserves, and it's just been really cool to be able to stand here before you and move my body. So it feels good. So keeping that in mind, mimicking nature, I kind of want to talk a little bit about we're cultivating these microbes, this soil life, but it's also important to understand their needs, because if we put them out in the soil and just hope for the best, we may be doing a little bit of a disservice to them, because everything is really dependent on community, and that's what we got here. And I'm so appreciative for all of you, because I actually have been a little under the weather lately, and if it wasn't for my family coming together, this presentation wouldn't be here. And I know there's a lot of other supportive people like Courtney and my fellow coordinators as well who've helped me be here in front of you today. So thank you, everybody. And so let's get started. All right, so first, I always like to do a little bit of, whenever I'm doing some soil restoration, again, building habitat, before we even build the habitat, let's get a baseline. So I do a little bit of a soil food web analysis, kind of just like Janelle's been talking about. This is my friend Vera, actually. She's really cool. If you guys were checking out Soil Palooza at all, that she was there kind of hanging out, talking to us a little bit. And so I'll send some soil samples out to her, and she just gives me a kind of a gist, like how much bacteria do you have? How much fungi do you have? How much predators do you have? And almost always it's bacteria and nothing else. So I think of it as kind of like a forest with squirrels and nothing else. It's really sad. But we have a starting point, and we have a measure, so we can now show someone we've made progress. Then, if possible, I like to do soil tests and kind of figure out, do we have heavy metals, salts, pesticides, etc. I'm working in a community garden, actually, with some of the people here today. We actually worked in an old parking lot, and it was super contaminated. I mean, it was literally just dirt where cars were parked for decades, so oil, who knows what. I mean, it had heavy metals of the yin-yang. It was really, really bad. And so actually CAC helped do some preliminary soil testing there, so we got a baseline, which is really cool. And I'll just kind of jump to the punchline. We fixed it in 1 year. It was edible. That soil you could eat from in 1 year. Thank you. Okay, so following that, water testing. So that's something that it may not be as necessary for tap water, although you can do it if you really want to. Chlorine, sometimes chloramine, depending on your region, it's a sterilizer. So if you're using sterilizer in your garden, in your compost, you're not going to get as profound. Like the microbes are pretty resilient. They will grow to a certain extent, but you're not going to get the results like we're talking about 1 year of regenerating soil, because we're suppressing that growth. So chlorine is something, and chloramine is something to worry about. When we're working with like people with wells, a lot of the times they test their water every once in a great while, but what they don't realize is that when you actually want to test your water twice a year. So, and it doesn't have to be every single year, but at least twice a year from the beginning, because we'll start that water test early in the season when the water table's high, and usually it'll give you a good idea of again what the water looks like when it's high. But then when you or your neighbors are pulling mass amounts of water out of that water table, the water table's made out of minerals. So literally they start concentrating in that water. It becomes a toxin. You start watering your crops with it. Maybe your crops can survive, but you're killing your organisms and you're destroying your potential. So, so again, I just want to kind of get a little bit more into some of the why, or some of the benefits of like, why are we building this soil habitat in the first place? And this list is limited. There's so much benefits, but I didn't want to I know we got dinner, and I don't want anyone to tackle me. But so we can see increased productivity for sure. When you get the community that the plants deserve and have literally evolved side by side with, you'll see increased crop yields, plant sizes, increased nutrient density. Something that most growers are not aware of, our soil particles, they're made out of infinite fertilizer. So we're over here thinking like, oh, when you farm, you're pulling nutrients out of the soil, you got to add it back. It's not true. The soil itself, the sand, the silt, the clay, the rocks, infinite fertilizer bound within that crystalline structure. But you need the community. So you take, the bacteria, the fungi, they break it down. You got the predators come, and they feed on those organisms within the root system, and they start cycling nutrients out of that crystalline structure. Free, infinite fertilizer, just like the forest does it. So reduced input. So I'm working over at this farm called the Pollen Ranch, and they got about 5 acres, and it's kiwis that they grow specifically for pollen. So only male crops, and they use tremendous amounts of water. Also, they spend a lot of money on fertilizer. So again, we do some of the soil layering stuff that I'm going to show you in a second. And in 1 year, we had reduced their fertilizer by 90% and their water use by 70%. Wow, damn, it's pretty cool. So pest and disease. These plants, again, community-based. So we a lot of times are thinking like, oh my God, why is the pests and disease just plaguing my plants? Damn you! Excuse my language, I'm sorry. But it's again, community. So what ends up happening is our plant surfaces, as well as the root zone, but they're supposed to have these beneficial organisms acting like the sheriffs in town. And when you are lacking in this microbial diversity, bad guy organisms show up, they take over, they attack, and maybe kill your plants. There's also other parts of that community on a higher level too, other habitating plants, etc. We're just talking about the smaller stuff today. Remediate toxicity. So we talked a little bit about pesticides, herbicides, all these things we got to worry about. Biology fixed that. So by creating the right opportunities for them to flourish, it gives us an expedited process of, like we were talking about before, the soil toxicity, those heavy metals that we had remediated because we had taken care of their needs. Suppressing weeds. Everyone's worried about weeds. And weeds are very biological in nature. They have very specific needs themselves. So the weeds, they like a bacterially dominated soil, which literally is what we just said that almost everyone has, unfortunately, is bacterially dominated soil. And that is perfect to grow weeds. But once you start getting the fungi present, the form of nitrogen changes, and then the weeds don't really like that nitrogen. And it feeds their trees instead. They prefer that, actually. So by changing the biology, we then start changing the plants, the environment, and then the weeds just kind of go dormant, which is pretty cool, until we screw it up and start tilling. Don't till it. So increased soil carbon sequestration. Nowadays we're having more significant issues with air quality, right? And we need to store that carbon in the soil long term. Our organisms can do that. And last but definitely not least, healthy microbiomes for people. So in nature, first I just want to say that there's a really cool article that, unfortunately I didn't include it here, but if you want information I can connect you to it. But it's the National Institute of Health, and they have shown that like our immune system is educated by the microbiome that lives on our skin, but we bathe in chlorine. And we have, again, our soils are rich in bacteria and nothing else. So where is our community coming from? Right? Where it's missing. So why are we getting so sick? We need healthy soil first. So we build a habitat for the soil. We go out there, we touch the plants, we touch the soil, and potentially start having healthier people. Oops. All right. I think I did this right. Yeah. Okay. So next. Sorry. Got a little lag over here. Okay, so quality water. So plants in nature start with quality water. So again, mimicking nature, we always just look, just like when the rain, typically, before we contaminated things, rain and waterways, the natural ways plants used to water themselves was very clean. So again, not chlorinated, not oversalted. So this is something that we have to keep in mind. There we go. So this is something we got to keep in mind if we want to expedite this process. Again, the microbes can sometimes, depending on that quality, they can still grow if it's not too bad, but sometimes a water filter can help. So I'm just going to show you a couple examples of some of the filters that I use. So we have, there's a garden grow, it's a little garden hose filter, and these filters specifically, the reason I like them so much is because I try to get people off buying stuff. I want you to be DIYers, I want you to be recycling and using your own stuff. You can take these things apart, and tomorrow I'm going to teach you to make your own charcoal. And do it in a way that is like, you don't need a bunch of fancy equipment, you don't need it, and we're going to light a fire that reduces emissions by up to 85%. So pretty much a smokeless fire, and then afterwards we look at our black gold, which you can use to make a filter. It's going to be really cool. Of course, other stuff too. So the garden hose filter is great. It works for small scale. You want to attach your garden hose, but it's got low pressure. So if you have a couple raised beds you want to attach it to, or you just want to walk around with your garden hose, that's cool. But if you want to plug it into an irrigation system, you're going to need more pressure. So that's where I use this high pressure other one, and again, it just unscrews and you can start using your own filtration media, and we could talk about that tomorrow if you guys want to learn a little bit more about how we can make that happen. So I like these because it's kind of like a potential one-time buy, and then once you're done with it, you then can just use the actual structure itself and plug it into your whatever system you got. At home, I used to use these, I still use them a lot in a lot of gardens, but I have a whole house water filtration system. I needed high pressure. I got a really big garden. I don't eat food from the grocery store. So I gotta have pressure. So that's what I use in my house. Large scale ag, not to get too much into them, but again, they need quality water too, so they have their own filtration systems. Clean inputs. So not everything can be pure. We obviously are going to be taking in materials from various sources that, you're getting fruit dropped off and it's maybe not organically grown. So there's these potentials for contaminants to come in, but we're going to do our best if you're going to buy a fertilizer or if you're going to do something or even ask the questions. Just asking questions is a great starting point. How did you treat this material? If you can't use organic fertilizers, if you're going to use fertilizers, not regular, I pretty much avoid fertilizers. Again, the soil is made out of it. I just focus on biology, but I just want to make sure that we're not putting in inputs that kills this, and then once you kill the organisms, then you stop this nutrient cycling, and then you can't use your dirt anymore as free fertilizer. Gypsum is something that a lot of people I've worked with used organically, sulfur as well. And especially with gypsum, they're just like, oh, it helps with my drainage and it helps with all this stuff. But in actuality, these things in the right quantities, they're a fungicide. They kill fungi. They kill the organisms that develop soil structure that allow the water to infiltrate. So it actually does the opposite. And so I stay away from this because we've done some biological assessments in locations where they've added gypsum and then where they added nothing. And the soil biology was off the chain where they were adding nothing. And it was like bacteria over here where they were adding and spending all this money. So don't add that if you can help it. Again, of course, no, you don't want to add all the chemicals if you can help it. So how some of our inputs affect diversity. So here you can see just a little bit of like if you need to grow bacteria, you got simple sugars, amino acids, proteins, carbs, plant sap, juices, young plants with a carbon to nitrogen ratio where you have a high level of nitrogen, not so much carbon. But again, we usually have deficiency in fungi. So we may want to focus a little bit on more fungal inputs. So again, seed coats, ground meals, fish oils, fish hydrolysate, kelp, fulvic, humics. These things are good for fungi. And again, wood chips too, right? So it's nice to know if you're missing fungi, what are the needs? How do we feed them? Neutralizing toxicity. So there's kind of this recurring theme. We have toxicity coming into the system. How do we solve it in an expedited fashion? So we have it in our compost, we have it in our soil, we have it in our water, feedstock, etc. I know Janelle covered some of the testing, which is really cool. That's not my specialty. I have a lot of smart friends who specialize in that, and they help me with it. But I am the one out there in the field making it happen, reducing that toxicity. So biochar is basically charcoal. We call it biochar because it's destined for the soil. We inoculate it with good guy organisms. That's where the bio comes from. And this charcoal has very magnetic properties. So all of a sudden, all these toxins start binding to it. And as they're binding to it, they're ultimately being held kind of captive so that the organisms can slowly break them down in a safe way, maybe even convert them into future fertilizer. Another great opportunity for that, for breaking down toxicity, is humic or fulvic acids. Again, they have these very electromagnetic properties to them. They bind to toxicity, holding it just in a similar fashion to the biochar. The great thing about these things is, yes, of course, well, yeah, you could buy them, but you can also make them. So free, we can do this for free. So the biochar, tomorrow I'm going to show you guys how we take like tree trimmings and convert it to charcoal. Again, using a conservation agburn, low pollution method, so we can then deal with their toxicities. And then we're going to be doing some extracts and some compost teas. And some of those extracts and leachates from quality compost has humic and fulvic content. That's where we can start remediating, making some sprays to spray on some toxic materials and start that binding process.
Okay.
Yeah, question.
Do you have a percentage for biochar use for like soil amendment versus remediation?
Yeah, well, so I kind of keep it at the same because you just don't want to go too high on your biochar. It can really make your, it just kind of gives to it doesn't help with the soil structure too much if you go too far. I think up to 18% is what I've seen work pretty effectively, but that's pretty large, and if you're buying it, biochar is expensive. So I usually lean towards 10%. That's kind of like my sweet spot. But if you're making it and you have infinite amounts, up to 18%, especially if you have remediation issues, totally. Is there any other questions relating to that or anything else we talked about?
From any plant, any trees, biochars are okay?
Yeah, pretty much. I mean, they're all going to behave differently. They all have different structures on them. Or when you convert it into a charcoal, they're going to behave a little, but they all are going to still have magnetic properties, and they're all going to give you the same quality. It may be a little bit less or more with different plants or structures. I've even heard too that if you want to, because the charcoal it's actually a home for microbes too. It's got all these beautiful little pore spaces, and if you want to make the homes a little bit more efficient for say you have a very specific amount or specific type of organisms you want to apply, I've heard of people actually sacrificing. They'll literally spray some of those organisms onto that char when they're first making it, so it's literally hot and it kind of like scalds into that char, and it almost embeds these little grooves and spaces so that it has this perfect size home so that the next set of those beneficials can move in. So there is opportunities for that as well. Is there any questions other than that? Yeah? Yeah, Janelle?
Biochar is also a great way to get rid of pesticides and contamination and stuff that doesn't break down in compost.
Yeah. So you can use it in your compost, you can use it in your soil, you can use it in a water filter. You can use it for it's actually been proven the equivalent to dialysis. So literally when you eat it, not only does it clean your digestive system, now I do this at home with organically grown wood materials, so I know for a fact they're not contaminated, and then I basically can consume that charcoal. It not only cleans my digestive tract, but your nutrients actually flow from your digestive tract through the walls into the bloodstream. But the char has such a strong magnetic affinity, essentially, that it actually can reverse that flow. And it can pull things from the blood through that wall into the char, or onto the char, and then you pass it. Yeah, so it's a medicine of sorts. I actually recommend keep some char on you, just in case you consume something unsafe. Maybe, I'm pretty sure, yeah, you can basically deal with some poison toxicity stuff in your body with charcoal too. Okay, so let's get into some of the good stuff. So, mimicking nature's soil layers. So in soil science, they kind of have some definitions that may contradict what I'm saying a little bit right now, because I'm not trying to be super sciencey. I'm trying to be more like, just kind of how I imagine something, and in more of a layman's terms way too. So I like to think of the soil layers as like our first layer is your parent material, your sand, your silt, your clay, your rocks, whatever your soil is made out of, basically. And then on top of that, you have your topsoil, which I like to think of as compost, because in actuality, that's what it is. The plants fall to the ground, they compost, and they become topsoil. Now, topsoil is definitely more biodiverse and developed than our compost, because it goes through a much longer maturation process, and there's all these layers and plants, and there's community involved in it. So it really creates a way super high-end compost, but they're very similar in a sense. So again, when I'm looking at nature, I'm mimicking nature, right? I see parent material, I see this topsoil that's just basically rich compost, and when I'm using compost in my situations, I'm usually working with municipal compost, and it's just like, as Janelle was talking about, it's hydrophobic sometimes. It's like really small particles, water repels off of it. You do more than 1 inch, you can't get water through it, and it can be problematic. So I usually keep just 1 inch, just to at least start that topsoil layer. Now if you want to get fancy, I even add 10% biochar, 10% granular humic acids. Now granular humic acids, though, is something unfortunately that has to be bought. Not too expensive, but that's again getting a little more fancy. Biochar you can make yourself again. So these are things that I typically incorporate, especially if I want to make things happen fast forward. So we've got our parent material on the bottom, and then imagine that topsoil on top, right, is our 1 inch of compost. Obviously, this is definitely not 1 inch here in the picture. And then I like to put my 2 inch layer of mulch, my edible root. So when I'm looking at it, I don't see these layers. I see a basement with, maybe it's a living space. Someone's living in that basement. They prefer to live in that basement. And then I got above that in that topsoil, I have another living space. So maybe it's your kitchen, your bedroom, etc. And then you have your edible roof, your mulch. So you don't want to disrupt these layers. You don't want to mix them. If someone was to take your roof and put it in your basement, how happy would you be? Right? You couldn't cook your dinner. You couldn't do a lot of things. You'd be pretty screwed. So respect the layers. This is how we have done a lot of beautiful stuff. Is there any questions in terms of the soil layer stuff?
Great metaphor.
Cool. Love it. All right. So if we want to calculate our compost / mulch needs, this is pretty much how I do it. So first you start by measuring your site area in square feet. If it's really small, you can use a tape measure. If it's a little larger, you can use the measuring wheel like you see here. If it's even larger than that, you can use Google Earth. And I don't have a demonstration on here for Google Earth on how to do it, but it's really simple. And tomorrow or Sunday, feel free, maybe even after dinner or something like that, come to me. I feel very happy to walk you through the process of using Google Earth to measure your site, get your area in square footage. So now that you got your area in square footage, we're going to utilize a mulch calculator tool. So my favorite, there's a bunch of stuff, there's tons of them out there. This is just like the easiest one I found. It just doesn't have too much on the website. It's not like, what's with all this extra information? So landscapecalculator.com /calculators/mulch. I'll have it again at the end resources page. You can take a picture. You can ask me later too, and I'll provide that to you. So you, again, keeping in mind, we're doing 1-inch layer of compost, 2-inch layer of mulch. The mulch calculator doesn't really matter. If 1 inch of compost or 1 inch of wood chips, it calculates the same way. So basically, the way the tool works is you put your area in square foot in the first little box. In the second box, you put your 1 inch for your compost, and you get your calculation. Then you repeat the process. You can either double it, because 2 inches is double 1, or you want to use the tool again, you just put 2 inches in there instead, calculate, boom. Now you know exactly how much compost and how much mulch you need for your area to do those soil layering processes to build your house. Yeah, microbial house. Okay, so chop and drop. So this is a really cool way to continue to build diversity in your system and just create another layer, another roof. It's like a second story to your house, essentially. I actually, with my fruit trees, a lot of the times I'll have like cover crops growing around them, and when they're done, I'll pull them and then I'll almost like weave them into a wreath, and I'll put that around my fruit trees, around my various trees. And so if you pick that up, you'll see all these little critters, roly-polies, etc., living underneath it. So again, it's just another story to it. So you have nitrogen fixers, root crops. I mean, you can use all kinds of fun stuff for cover crops. Look up cover crops. There's a whole variety of crops to use. I've used weeds plenty of time. If you're scared of seeds, or them reproducing in your system, try to pull them before they go to seed. It's helpful. As long as they're not like a rhizome type or mutagrass or something crazy that you set it back on the ground, it's going to take off. They can also give you free fertilizer and a second storage. And potentially avoid disease plants if you're like, especially if you're a newbie. Me, I actually sometimes will go to my neighbors and I'll take their blight from their apple tree and I'll personally infect my tree just so I can show that I can cure it with soil glue web. But I don't recommend everyone do that. It does take a little bit more experience. So edge systems. This is a really cool kind of example of a forest where it kind of meets like a grassland. And I love this because forests have their own set of organisms. The grassland has its own set of organisms. That edge has a very specific niche set of organisms that love that little area. But interestingly, not only do those niche organisms live on that edge, but the forest organisms come to the edge, and the grassland organisms come to that edge too. So when we create edge opportunities, we increase the opportunity for biodiversity. More biodiversity means more opportunities, more free labor, more super scientists made by nature. These microbes, again, they're working on a chemical structured level that most of us don't even completely comprehend. But they're super smart, they're super capable, so let's just provide them with the opportunity. Some other things we can do is like curved crop rows instead of straight. That having those undulations or those curves allow for shade and different pockets to kind of occur. Instead of this consistent line of everything uniform, you have a little bit more moisture here, a little bit less airflow there. more opportunities for diversity. You can also get actually more crops growing that way too, in the same amount of space. Crenulated pond, all that just means is just like a really wavy edge pond. So you have, again, it's kind of like a curved row crop system. Keyhole gardens. Does anyone know what a keyhole garden is? Yeah. So, but yeah, so the idea is it's just kind of like a cul-de-sac essentially. And so when you have, imagine, you have a road coming up into a cul-de-sac, and if you were to stand there, kind of, I think Dave was talking about this earlier, how the sun is moving, you have these different shade areas, kind of, again, there's these different kind of environments occurring throughout that keyhole, which allows for diversity to occur, which is pretty cool. Fences, this is like one of my favorite things to do. I'm actually going to be doing this over at Decoy Riverlands Trust. We're going to be taking pallets. So we take just, preferably, I mean, I know they're unfortunately sometimes sprayed with stuff, but we're trying to be, conscientious and recycle things. So we're taking pallets, some garden stakes. We stand them upright to break the wind, and then we throw like a little bit of compost, a little bit of kind of do some soil layering around it and stuff. And have you ever noticed like when you have a fence and all that trash is just building up in the fence? You ever go into nature? It's not trash that's building up in the fence. It's plant material, it's seeds, it's things being caught from nature. Not only that, but it's a great bird perch. Birds fly in. When birds land and then they fly away, they like food, free seeds, free fertilizer. So, and then just that process of exchange, them coming into the system, dropping, touching things, we're bringing in more biodiversity in microbial form too. Swales is something can also be an edge. It's basically just a groundwater. Does anyone know what a swale is? I know. Okay, we got some swale people in here. So I like to do them too in flatlands. A lot of people think of swales for hillsides, but they kind of forget about the flatland. And I do I call them infiltration pathways, but really it's a swale in the garden, and that is in the middle of your pathway, and it's topped off with mulch, so it's level. You'd never know it's there, other than the fact it's a little spongy. But it's really cool because you're not just recharging the groundwater, which actually I can draw. Can I erase this? Does anyone need this? I'm gonna talk a little bit louder. So, ooh, I got green. Got okay, so say we have your ground level right here. Here's your sun. And make like a little, say it's a 2-foot hole in the ground. Compaction layers run horizontally. So that means that you'll have, I'm going to make them a lot wider, but say this is, because this is not to be, it's not going to be to scale. But say you have these compaction layers here, and most compaction layers usually are found within the first couple inches. So 2 inches down or so is where you usually find your first compaction layer. So imagine now got water. I'm going to get the water marker out. So we got a cloud coming in, dropping the rain, and so this starts filling with water, and water will run sideways along these compaction layers, which is pretty cool, because now we filled this with mulch, so this is topped off with mulch. You can't even tell that whole there. You're not going to fall in the story. But you can walk on it. It's a pathway. It's spongy. And you can grow trees on both sides. You could even use the dirt here to make mounds if you want for those trees. Or, instead of having trees on both sides, another option. I mean, honestly, trees are going to be the most beneficial. But another option is maybe a raised bed. And the raised bed could be filled partially with some of the dirt as well, so it offsets your potting mix, right? But trees are going to benefit the most because notice this tree, where are its roots? Right? They're right here in these compaction layers where the water is being directed towards those roots. That's how we can start getting plants off of needing so much water. And we have pathways. So your pathway is going to exist anyways. Might as well make it multi-purpose. And again, it's an edge in a sense because you have something different here than what's going on here. So organisms that like this kind of heavy mulch, extra moisture layer, etc., we're going to have more of them hanging out here and have some different diversity over here. Right. So, let's move on. Yeah.
So you were saying that's about a 2 foot?
Yeah, so technically...
And how long do you make the trenches?
It really varies. So like for instance, if I'm in a garden and we're planting a small food forest and it's got like, a 20-foot run of trees, then we'll make roughly a 20-foot, just imagine that inner row space all the way down the center of it. And you don't have to do the entire pathway. Sometimes your soil is so tough that it's challenging to dig this much soil out. So I'll just do 1 2-foot wide by 2 foot. You want to go a little deeper, you can go a little deeper. I haven't experimented too much with going too deep. In the back of my mind, I'm a little hesitant to go too deep because of the fact that I don't want this material to get super compacted down and go very anaerobic. I'm trying to kind of keep a little bit of oxygen in the system because the oxygen-loving organisms, they love soil structure. They want your soil to breathe. So if you have too many anaerobic organisms in your soil, and your soil's compact, you're gonna be like, cool, this is awesome. I don't need to fix it. This is great for me. I love compact soil. I don't need to breathe. But if you have more aerobic organisms present in your system, they're gonna be like, you know what, I don't like this compact soil. I don't like this compaction layer right here. I'm gonna fix it. And they'll start breaking it down, and they'll start opening that soil structure up, allowing for the air and water passageways to take place. And then your trees do tremendous things. So we've done things like this, and not only have I seen I have some fruit trees I planted in my backyard. Again, don't eat food from the grocery store. So went to the nursery, and I'm like, this $30 tree, when do I feed my family? I'm gonna plant it tomorrow, when or today. When do I feed my family? And they're like, probably 3 to 5 years. And I'm like, challenge accepted. So I go home, I plant my tree. I did a bunch of very different planting, I did not use the normal soil, the recommended planting practices. And then I did these infiltration swales, brought the community over. It was really fun. We all got involved together. And ultimately, the trees, which were again, maybe 3-4 foot tall or something like that, they were pushing 16 foot tall next season. I had 300 plus fruits. So I went back to the nursery, and I was like, hey, you remember me? I'm feeding my family. And they're like, what are you talking about? You're crazy. And so I was like, no, this is what I'm doing. And they're like, oh, no one's doing that. And so then they were like, okay, cool. I'd love to come check it out. So they came and check it out. The next thing, agriculture's coming and checking it out. They're like, wait, your tree's bigger than my 15-year-old tree. Because this is by the time they heard, it was year 2, year 3, but it was bigger than their 15-year-old trees. It's healthier, more productive. And they're like, what's going on here? You don't water? I'm like, sometimes. You don't fertilize? I'm like, I use compost teas. I focus on biology, but I don't focus on all the other stuff. And so this is some of the benefits we got. Question?
Yeah, I had a question. Would this stuff also apply to for the hard rock layer that was a lot of these in Central Valley at your hard pan, there you go.
Yeah, clay, right?
Yeah, it's really hard to get through with that.
100% will solve that issue. So yeah, the clay itself, if you want to get fancy and sciencey, they call it flocculating. And really it's just the biology going in, and they're using electromagnetism. Again, they're super scientists. and they're binding these, I think it's, if I remember correctly, I think it's positively charged calcium ions. I don't want to get too deep. But the point is they basically are causing these clay particles, which normally look like plates. Imagine your dinner plates all stacked one on top of each other. No air and water flow. But then when you put these positively charged particles on those surfaces, think of positive and positive. What do? Right? They repel each other. And so all of a sudden the soil opens up, starts breathing, the water starts infiltrating, the roots start moving, the microbes start flourishing, the ones that these roots depend upon, the community. So yeah, it can help with that. Is there any other questions?
With your swells like that, have you ever experimented with inoculating with like edible mushrooms? And have you ever got growth off of them?
Yes, I have. So I've used oysters, I've used a variety of mushrooms. Typically though, those types of, because if you really look at those edible mushrooms, like how do they grow them in these gourmet type facilities? They sterilize, right? So I put them out there, and then after 1 or 2 flushes, they go away. They finish feeding on the material that I actually put out there, that leftover grain spawn or sawdust or whatever, I put out there, and they can't compete with the other organisms that are really built for that wood chip, and they're already pre-existing on it. So I don't get continued. There are certain varieties. I think the Garden Giant is one that Janelle has utilized, and those are very competitive, and so that might be a really interesting one to kind of experiment with. But yes, I have done that, and I use them all the time. And actually, getting back to the whole layering system, I sometimes not just include the granite humics and the biochar in that compost or that topsoil layer, but I'll stomp, do a little rain dance on some mushroom blocks, break them down into smaller bits, and I'll mix it into that as well. And so that kind of creates a little funky component. Yeah, Lloyd.
I was going to say a good method that we use a lot of humble solid wet, and there's tons of mushrooms everywhere. You put a thick layer of straw down in like a shady kind of fumbly type area. Let like Stropharia or whatever mushroom like naturally inoculate into that. Once it starts to bloom, you can take those mycelial chunks, spread them out over more carbon.
Yeah.
And just you're basically like kind of wrangling those native microbes, native fungi, seeing what pops up, what they like, and then figuring that out. So.
Yeah, and Stropharia, that's the Garden Giant, right?
Right.
Yeah, so that, again, that's a very dominating type of organism. So that's, again, something that's a great idea. Thank you, Lloyd. Any other questions relating to the swale edge system? No? All right, we can do it. All right, so additional housing. So we got rocks and boulders. So, I mean, if you ever look under a rock, you see life. There's very specific, I mean, also a lot of times you'll see like lizards and other things, and so it brings in more diversity. So rocks are really important. They have like a heating element, which again the lizards appreciate. But logs, something we see in the forest all the time. And we grow trees all the time, but we never really think about like how do trees grow in nature? There's wood material, not just wood, they don't necessarily have wood chips, they have logs, they have leaves, they have stuff. And so these logs are really cool. They just create like a third story to our house, right? So the logs are really cool, and they create another layer of housing. Clay pots, it's just maybe not something that's, sorry, I thought I saw him. It's not something that is you'll see with in nature necessarily, but we make clay pots, and every once in a while I'm in my garden and I move it, and whoa, roly-polies, they're all frolicking around. So another additional housing. One thing that's left out on here though is biochar. Biochar is an exceptional housing structure. I forget the numbers, I'm kind of making something off the top of my head, but basically it's an extraordinary number. Something along the lines of like a little gram or a small amount like in your hand has like enough surface area for like a tennis court or much more or something like that. So imagine how much bacteria can cover a tennis court, and then you can also now fit that in like the palm of your hand essentially. Like we can really grow plenty amounts. We can really exponentially grow more biology in a smaller footprint. It's almost like New York City, how they're just, they go up rather than out. although it's a little bit different. But that's the way I kind of think of it. So yeah, biochar has the ability to be exceptional housing. Yeah, so that's an additional bit. So now that we have the layering, you know, we've made sure our water is good, our inputs are on point to the best of our ability, we're handling toxicity, we've created a really cool multi-layered house. Now we finally, confidently release the soil food web. So there's various ways to do this. Compost teas, you can actually see, so this is the pollen ranch that I was talking about earlier where we reduced all that water and fertilizer. This is a very special piece of equipment that Dr. Elaine Ingham has shown that the microbes, you can spray it through, because a lot of conventional agricultural equipment is unfortunately, it's not meant to spray living organisms. It's just meant to spray chemicals, dead stuff. So they're not thinking about how a filter or a right angle or a high blood pressure might disfigure, destroy, crush, rip apart a living organism. So this is a spray system that we're using to apply to organisms. And compost tea is really cool because when you make a compost tea, the organisms are essentially making these organic glues. So when you spray it on the plants, they adhere to the plants. They colonize the plant surfaces. They don't just run off. Awesome. With compost extracts, it's something that we, again, do at the pollen ranch, but we do it via irrigation because the extracts are not sticky. It's something, again, this is what we're going to be doing tomorrow too. So for anyone that wants to do compost tea, compost extract, biochar, I'll be doing all three, and feel free to join me. So compost extract is, we're not multiplying the organisms, we're actually just extracting them purely off the surfaces of our compost, or vermicompost. Sometimes compost, especially if we're making it from waste, may not be like high enough level in biodiversity to really want to make compost extract and go through all that effort. So I always recommend take it to the next level. Make it a vermicompost. Feed your compost to some worms. Let their gut biology really take that diversity and so that life to the next level. Then make an extract. Then you make a compost tea. You can make compost extract now. Again, we didn't multiply the organisms, so they're not sticky. So now we can run it through the irrigation. It's less likely to adhere to the insides of your irrigation, less likely to clog your irrigation outlets. And the great thing about it not being sticky is, imagine if you had sticky organisms and you drop them onto mulch. What are they going to do? Yeah, that's exactly right. They're going to stand on top. They're going to stick to the mulch. They're going to stick to the upper soil layers. They're not going to infiltrate into that root zone. But if you have an extract with no glues or very minimal glues, they can infiltrate deep into that root zone, colonize it really way more profoundly. So that's a huge plus. So that's how we're going to get the organisms on the plants, in the soil. Another way you can do it too is you can just literally just put the compost on the soil, kind of like we talked about before. But again, most compost, unfortunately, doesn't have the soil food web. Even when we make it ourselves, it has some bacteria. It has some. That's why it's really cool to be able to do like what Janelle's going to be showing you guys on Sunday. Using the microscopy, the microscope. It helps a lot to identify am I actually releasing a full-on community, or am I missing something? And then again, maybe take it to that vermicompost level. Maybe do a couple extra steps to make it next level. But a compost application with a complete soil food web is huge. And then same thing, vermicompost application. So you can literally put the vermicompost on top of the soil too. And when I do the compost or the vermicompost on top of the soil, again, we put our mulch roof on top. Because when the sun hits it, it starts killing things. When the UV rays start sterilizing, it doesn't kill everything because obviously we can walk around in the sun, plants can sit out in the sun, and biology still lives there in the sun. So sun doesn't kill everything, but it will dehydrate, it will cause things to go dormant. Some of those organisms cannot survive in that UV light. You lose your diversity. Diversity is key. So I think that is it. So I guess just real quick, my website, regenliving.net. There's great content in terms of we have a Learn More section. And you can go, there's just all kinds of, we're working on our YouTube channel, we're not there yet. Got a bunch of recorded stuff, I'm really bad on the editing and uploading portion. But there's all kinds of really great content creators that have highlighted, and it's like one for instance is about how the Amazonian people created fertile soil in an infertile situation. Okay, so I'm pretty much on time. A couple minutes, sorry, give me 1 second. So so basically the Amazonian people, they were living in a situation where they couldn't, the soil wasn't conducive to the crops that people eat. So you could sustain large populations, but they figured out how to make super soil. They called, the Spaniards came in, they called it terra preta. And here in North America, the natives did it, and our scientists called it mollisols. But there's a really cool video, definitely look for the history of El Dorado. The story of El Dorado, about biochar, it's about the soil food web. So check that out, maybe check out some other stuff. thesoilfoodweb.com, if you want to check out Dr. Landingham's courses, not pushing in any way, I just thought it was a really great course that I took, and you want to learn more, or just maybe start following them on social media and stuff, they're pretty cool. Discoverpermaculture.com, that's my permaculture teacher's website, and he's got a free permaculture circle section, so you can start learning a little bit about permaculture for free, which is awesome. And then again, there's the landscape calculator. So last, do you have time for a couple more questions? We gotta go. 2 questions.
In the neighborhood farm where I work, tomorrow we are doing compost pile. We have been using the city water for the last 7 years.
Mm-hmm.
And I know city water comes with some chlorine.
Yeah.
What I'm expecting, based on experience with the previous speaker and you, chlorine staying there and killing my land, or what is going on?
Yeah, so to a certain extent, it's like, I mean, as you're making compost and you're building soil, it's somewhat getting remediated, but yeah, if you can mitigate that by having a filter and making your own charcoal, which we're going to be making charcoal again tomorrow, so we can kind of show you how to make your own filtration media that you can grow your own filters essentially. You might need to buy the housing structure the initial time, but once you own that housing structure, then you can start expediting that solar generation. One more question. Any more questions? All right. Peace, everybody.